Hi there, my name is Caleb Baechtold, and I'm a principal architect for AI and machine learning here at Snowflake. Today, I'm going to be walking you through a demo of how you can augment BI with AI using Cortex Analyst in Snowflake. Cortex Analyst is a brand new managed AI service in Snowflake that allows business users to talk directly to their data using natural language. Let's jump right in. Walkthrough is available as a quick start on quickstarts.snowflake.com. We can find it just by going to Quickstarts and searching for Cortex Analyst. Of course, we'll also post the link to this quick start in the description here below, but we're going to be going through this getting started with Cortex Analyst, Augment BI with AI quick start to show you how you can use Cortex Analyst to talk directly to your data inside of Snowflake. As I mentioned kind of in the intro here, Cortex is a managed service that's available in Snowflake, and it's exposed as a REST API endpoint that allows any application to, interact with the LLM service to ultimately provide structured data responses to natural language questions based on a business user's input. So we're going to go through kind of all the steps needed to get Cortex Analyst up and running. Ultimately, what we're going to do is build a Streamlit application that has a quick chat interface that allows us to ask these natural language questions and get the corresponding, query results and everything like that come back. And of course, because this is a REST API, Streamlit's not the only way to interact with it. Basically, any place that you can connect to Snowflake from, any application can start to incorporate these capabilities directly in. There's three kind of main parts to getting Cortex Analyst up and running with your data. The first is your data itself. The second is the semantic model, which we'll get into much more detail a little bit later on. And then the third is the application interface, basically what's the thing that's communicating with the service over REST. From the quick start, we have links to, of course, the documentation, which includes a lot more detail, kind of what Analyst is and how it works and the RBAC and all that sort of stuff. And then the second piece that we have is a Git repository that has all of the source code needed as we'll walk through different steps today. The main things basically that we'll need are going to be configuring our Snowflake environment with some data. This demo uses some basic revenue data, time series, revenue, profit kind of information over different products and geos and categories and things like that. We have then the Streamlit application code itself, the data, and the semantic model, which I mentioned we'll get into in a lot more detail a little bit later. So to get started, the first thing that we need to do is, of course, clone the Git repo, but then set up our Snowflake environment. So in the Git repo, there's a create snowflake objects.sql file, which we will open up in Snowsight and run. This is going to do kind of those basic setup operations. So we're going to create a database, a schema, a warehouse that we're going to use over the course of this demo, a stage, which is where our data is going to go, as well as the semantic model YAML file, and then create some tables. So I mentioned this is some revenue data. So we have three different tables that we're going to use and ultimately talk with via natural language. We have daily revenue, which just has some by day revenue, associated COGS, forecasted revenue. We have revenue by product, so same kind of data, but we have a product line as well. And then we also have revenue by region. So this will be, revenue by state, city, country, whatever kind of region you might be. I've already run through these sort of steps, run this code directly. So you can see I have over here my Cortex Analyst demo database set up with my revenue time series schema that has my three tables created. And that just happens by running this create snowflake objects SQL script. The next step is going to be to actually ingest the data files. We can do that a number of different ways. An easy way to do that today is to just go to the database and schema itself. So if I go to my revenue time series, go to that raw data stage in Snowsight here, you can see I've already uploaded these files, but I can of course just click add files and then drag and drop them from my local cloned Git repository here and then upload them. And again, those are going to be the four files of the daily revenue by product combined, daily revenue by region combined, and the revenue time series YAML file. Once I've brought those files into my stage, the next thing I'm going to do is just run a copy into statement for each of my 3 tables. So there's in the Quickstart here, copy into for daily revenue by product, specify the files, and then daily revenue by region. And again, you can do that just from a SQL worksheet. So I can run those copy into statements here. And again, I ran those ahead of time just to kind of get things up and running. So if we go back to that database, check out the tables, we can go to our daily revenue table and do a quick data preview, and we see, okay, we've got basically 2 years of revenue data, where I see here by date, I have the revenue, COGS, forecasted revenue. By product, looks more or less the same. Date, product line, revenue, COGS, forecasted revenue. Daily revenue by region. Same thing with the sales region associated with it here. So you can see we've got some continent level kind of geo data associated with the revenue, COGS, all that sort of stuff. Now, of course, if you're a data engineer and a SQL analyst and that sort of thing, these are pretty flat tables. It would be relatively straightforward to start writing SQL with and interacting with. But if you're a sales ops person who cares about the data in these tables but is not a SQL analyst or is not a SQL expert, but you still want to be able to ask questions kind of ad hoc about this data, this is normally you do this by going back to your data team and asking them to build out new pipelines or whatever it might be. Cortex Analyst, we can provide an interface directly on top of this data as an application without having to do all of that manual SQL work ourselves. So that is what we are going to jump into next. Because we have that semantic model, we can just get right into using Cortex Analyst. I mentioned we have it. It's available in the GitHub repository for the Quickstart here. You can go, this is the revenue time series YAML file contents. I'm not going to go into it quite yet. We're just going to show this up and running first, but then we'll go into a lot more detail about the contents of this. Is ultimately the data coupled with the semantic model are the 2 things that really make Cortex Analyst powerful for your specific data. To start using Cortex Analyst, we're going to run a basic chat interface in a Streamlit application. So in that GitHub source code, there's a Cortex Analyst Streamlit.py file, which you should have cloned to your local environment, that has basically a pre-built chat application that allows us to start interacting with Cortex Analyst. So to get this up and running yourself, you'll want to open up this .py file locally, and you'll just need to change a few of these parameters here. So you'll need to supply your Snowflake account URL, which will be your org-account name, .snowflakecomputing.com, or if you don't use organizations, it'll just be your account name, .snowflakecomputing.com. And you'll need to specify your username and password and the account URL here in these 3 lines. Basically, that just allows our Streamlit app to connect to Snowflake account and authenticate so that then we can use the Cortex Analyst API. I want to point out before we look at the app itself, the app, is about 125 lines of code or so. Basically, it's a very basic kind of chat interface using the Streamlit library components to take in input text and then call the Cortex Analyst REST API. And really the piece that does the work, I should say, is this send message function. So I mentioned that Cortex Analyst is a hosted AI service in Snowflake. It's managed for you, and it's exposed through a REST API endpoint. And so in the send message, basically what we're doing is taking the input text prompt or the input question that a business user wants to ask, packaging that up as a JSON request body along with the location of our semantic model file. So our semantic model file is the one that we uploaded into our Cortex Analyst demo revenue time series raw data stage. So if I go back and take a quick look at that here in our raw data stage, you'll see here we have this revenue time series.yaml file, which is located in that full kind of database location. So the send message function takes the input prompt specifies that semantic model file location, and then submits that request to the Cortex Analyst message REST API endpoint that Snowflake makes available to you. So you don't have to set this part up at all. This is, again, the managed service piece that we're running for you in the background. We've in the Streamlit app basically packaged up that request body. We use our NoPark session here to authenticate against the endpoint and using the authentication token. And then we submit the request to the Cortex Analyst REST endpoint. And that's basically all there is to it. So to get this Streamlit app running locally, again, you'll want to edit this file and just make sure you've got your account locator info, your username, password, authentication. You can use basically any of the supported connection methods from Snowpark and the Snowflake Python connector. So if you use external browser auth or whatever it might be, you can use all of those as well, of course. But you'll change those parameters to include your information. And then you just want to make sure you have a Python environment that has Streamlit and the Snowflake Python APIs installed locally. And then we're just going to run a quick Streamlit run, Cortex Analyst. So Streamlit run and then the file name, basically. And this is going to spin up a Streamlit application in my web browser running locally, where you can see here we've got Cortex Analyst. We're printing the specific semantic model that we're using here. But now I have a chat interface where I can begin just with, what questions can I ask? As an example. Maybe I don't know where I want to start, but I can just start saying, what questions can I ask? This is going to submit that and say, this data model allows you to analyze daily revenue and related metrics, such as cost and profit for different product lines and regions. Here are some suggested queries that I might want to run. I'd say, okay, great. So what is the average daily profit for the clothing product line year to date? Let's just run that one. It's going to submit that question to the Cortex Analyst REST API. Then it's going to come back and say, this is our interpretation of your question. What is the average daily profit? Below is the SQL that answers your question. But also importantly, you'll notice here we have just the results themselves. So we actually just spit out the average daily profit for that particular line year to date is $1,407. Now, if we want to, we could actually look at the SQL query that was generated to answer this question. And so this is really the work that Cortex Analyst is doing. The first piece is you ask a natural language question. The Cortex Analyst basically interprets that to say, what is the question that you're actually asking? What is the SQL that can be used to answer that question? Is that SQL valid? We check, of course, that it's valid SQL and a number of different things, and then actually execute the result to get the answer. And of course, I could then ask, so we have those suggested questions here, but I could ask different ones too, which is, what is the total daily COGS for North America? As a different question than those suggested ones. And let's see what spits back. Below is the SQL that answers that question. What is the total daily cost of goods for North America over the entire available time period? Below is the SQL that answers your question. So you notice that this may be slightly different than what I intended to understand. So I asked for total daily COGS. That interpreted that as what is basically the sum of COGS for this region over the entire period. So we see start date, end date, total daily COGS. What if I instead actually said, what is the daily COGS for North America? If I wanted to see it actually by day instead of just the total sum, might ask the question slightly differently. But I wouldn't even necessarily realize that. And you see here the results that come back are, we have then by day, the daily COGS value. You can see what is the daily cost of goods for North America for the entire available time period in data. And so here you'll notice that it took total in this question to mean sum. And so part of what the analyst does is it says, here's how we understand the question that you're asking. And here's the SQL. And you might say, oh, actually, that's what I was looking for, is a slightly different question or something like that. And so let me just rephrase the question slightly. And this might actually get then to the question that I wanted to answer. And then, of course, because we have the data in Streamlit, you can very easily write Python code that allows you to visualize that data as a line chart or a bar chart or kind of whatever makes sense depending on the particular question that you're asking over top of that data. And so I have total flexibility to ask any questions I want over this revenue data set from this chat interface. And again, the real power of what is making that possible is, one, of course, the data itself. But the second piece is the semantic model. So let's look at the semantic model in more detail. So the semantic model is what tells our LLM service how this data is best understood, essentially. The semantic model is exposed to the service as a YAML file, which we looked at previously in our repo. And ultimately what it does is it defines like the tables, the columns, the fields that are relevant in the data set so that analysts can run queries over the natural language. The big thing is that you don't have to just explicitly lay out like every, you're not confined to exclusively the columns that are present in the tables that you might want to query over. So in the case of this particular YAML file, let me pull that back up. You'll see that we have different sections for different tables. So we have our daily revenue, we have a description, we have information about where is the base table for that particular table. And then we basically have what are called dimensions and measures. So dimensions are fields in the data, essentially. And then measures are quantifiable columns that are relevant to the particular kind of business application that we're looking at. So in our daily revenue table, let's just go take a quick look again at that raw table. You see we've got basically date. By day, we have total revenue, we have the daily COGS, and we have forecasted revenue. So very simple. Essentially what this boils down to is we have a time dimension, which is the date field. This tracks, information over time. And then we have 3 different measures, which are the revenue, COGS, and the forecasted revenue. We don't have any dimensions in this table because we don't have something like product line or region, like a categorical field or something like that. And so in the semantic model, you'll see for the daily revenue table, we have that time dimension, which is just the date. We have a quick description of what that field is. This is date, date with measures of revenue, COGS, forecasted revenue. And then we have our 3 measures. We have our daily revenue, which is total revenue for the given day. You'll notice that daily revenue is our dimension name, even though revenue is the column name. So you can see the expression for daily revenue is just the revenue column. We have a description, and then we have synonyms. The synonyms are what get to be very interesting because the way that different users talk about this field, or they might use different synonyms to reference this data that are different than what is the columns are actually called themselves. So for doing kind of revenue analysis, you might talk about sales or income as the way to talk about revenue in addition to revenue itself. And so we can specify kind of those business specific synonyms in the semantic model to help the LLMs understand, okay, if I'm asking about sales, I'm really asking about revenue in the context of this business application. And we have similar things for daily COGS, daily forecasted revenue, things like that. Now, what gets interesting is we've also added another dimension, which is profit. So we have revenue, COGS, and forecasted revenue, which those are just fields in our table. But we also know that, in thinking about revenue, we might also want to talk about profit as specifically the difference between our revenue and our cost of goods. And so we can define an additional measure, which is daily profit, which is just the difference between revenue and expenses. So you define here, notice before we had the expression just referenced the column name for each of these measures. So when I ask about revenue, I'm just talking about the revenue column. When I ask about daily COGS, I'm just asking about the COGS column. But in profit, that doesn't exist as a column in our data, right? We just have revenue, COGS, forecasted revenue. So I can instead specify profit, a particular expression, which is it's the delta, the difference between our revenue and our COGS fields. This is expressed as another number. And then we can also define maybe a different measure, which is our forecast error, where we look at the delta, the absolute value of our forecasted revenue compared to our actual revenue. So in the semantic model, you can define some of these additional measures that aren't present explicitly in the data columns themselves. I mentioned before, we just have measures in the revenue field. In the case of the daily revenue by product line table, we also have dimensions, which are the product line in this particular case. So if we go look at that daily revenue by product again, see in the data preview, we have date, product line, and the same sort of measure fields associated with it. So in this case, we specify the product line as an additional dimension. where we have associated revenue for each daily product line combination, essentially. And so that we maybe specify some sample values for that. This helps with how analysts might suggest different queries that you could ask. So you notice when we asked what questions can I ask, it said you could look at, total revenue for electronics by day or something like that. And then we have the same thing essentially for the daily revenue by region, where we have the sales region as an additional measure. And we have sample values associated with that and things like that along the way. And so those are really that semantic model is ultimately the kind of really strong bit of information that analyst needs to provide super high accuracy results over the natural language questions that you might be asking over these data sets. We also have some open source tooling to help with constructing these semantic models, which is worth checking out as you get started beyond this. But again, this is really where the power of analysts resides in terms of unlocking the LLM's capability to answer these natural language questions over structured data. Now, one other element of the semantic model is something called the verified query repository. Now, what the verified query repository is basically a selection of validated and verified queries that we know map to specific questions. Now, you might think to yourself, okay, that's kind of weird. It seems like if we do that, then what's the LLM doing? Basically, the verified query repository is sort of a bank of this question maps to this query. But where this gets really important is not just in providing that kind of sample bank of queries, but also as input to the LLMs for similar queries. So in our revenue time series YAML, you'll see we have some verified queries down below, things like daily cumulative expenses in December 2023, where here's a particular question, it was verified by someone at this particular date, and then here's the corresponding SQL that we have verified. A data analyst or an engineer, whoever it might be, has verified that this particular query provides the correct answer to this particular question. We have something for lowest revenue each month. What was for each month, what was the lowest daily revenue, and on what date did that lowest revenue occur is ultimately the question. This is the corresponding SQL that has been verified for it. Now, again, what we're not doing with the verified query repository is just saying oh, you already asked this question, I know the SQL to answer it, I'll just go run that SQL. Now that may be one use of it, but what's more interesting is if you have a verified query that's what was the profit from California last month, and you have a particular query here, and then you instead ask at a future date, what was the profit from, I don't know, we'll say Texas last month, rather than go through kind of the whole LLM architecture to generate that query, we'll say, okay, we already have this verified query that answers that for a very similar question about California. We can supply that as basically input context to the LLMs to then simplify the query that gets generated, where the LLM then understands, I just need to replace the filter value in the state column to answer the same question that was asked from a previous verified query, as one example. In the case of the revenue time series YAML, if I asked for what is the daily cumulative expenses in December 2023, and I instead now wanted to ask what about the daily cumulative expenses in January 2024, again, the existing SQL query serves as additional context to the LLMs to say, this is a very similar question. Here's how we answer that similar question. How do I need to modify this query to answer the new question, basically? And so the verified query repository allows you to do all of that. We have, as mentioned before, an example of basically an open source Streamlit application that helps create verified query repositories. So you can ask questions of Cortex Analyst and then basically validate and add those to your semantic model interactively, and then upload that semantic model to your Snowflake account. So we have a semantic model generator repo that's publicly available, which includes the semantic model generator, where you can specify, I want to generate an initial YAML for a particular database schema, etc., things like that. But it also has the admin app, which is a Streamlit application that allows you to iterate on your existing semantic model, create a semantic model from scratch, and then add things like verified queries, all in sort of a chat interface. So it's very straightforward to install and set up. You can run it, again, locally as a Streamlit app, connect to your Snowflake account, and start to incorporate known queries into your verified query repository, and ultimately improve the performance of Cortex Analyst further beyond kind of what we might build from scratch as well. So that's a very kind of useful way to, again, improve quality of the responses and ensure that you're maintaining a really high standard of accuracy for the outputs and the results that these LLMs are ultimately generating. And that brings us to the end of our quick start. So we showed kind of the contents of our semantic model file and ultimately how to interact with Cortex Analyst via that REST interface in a Streamlit application, giving you that natural language interface to your data directly without having to write manual queries and all that sort of stuff, and just talk to the data in the way that a non-technical business user might. Thanks for following along. Hopefully you found this demonstration useful and informative. If you liked this video and want to see more content like this about all the new AI, machine learning, data engineering, and data warehousing capabilities, applications, all kinds of stuff that Snowflake is building, make sure to like this video and follow and subscribe to our YouTube channel. We look forward to seeing you again sometime soon.